So in this example, instead of dealing with the half-life of an element, we're going to deal with the doubling time of a bacteria. We're going to still use the same equation we've been using before, our exponential growth and decay equation. And like before, our first step is to figure out what this growth constant is going to be, the K value, using the information that we have. So this tells me that I'm starting with 1200 bacteria, so I can put in 1200 for my initial value here, the P sub 0. I also know that I'm going to double in half an hour, so let's use that information to try to solve for K. So if I double from 1200, that becomes 2400. E is just a constant, and then K is what I'm looking for, and then I have to put in my time. Now I need to be a little bit careful here. I can either put in 1/2 an hour or I can put in 30 minutes, but I just have to make sure that I keep it consistent. If I put in 30 minutes to start, that means that from here on out my equation will be done in minutes. If I put in 1/2 for t, that means that from here on out the equation will represent number of hours. Now I'm going to choose to do this as minutes for the simple reason that I know later on I have to answer using minutes. So it's really easy to use minutes here, and then I can just convert the 4 hours to minutes to 240 minutes. It's much easier to do that than it is to convert 70 minutes into hours, just because I'll have to end up with a fraction. I mean, it's not that difficult, but just kind of thinking what's going to be the easiest thing going forward. I'm just going to do everything in minutes. If you choose to do it in hours, just make sure that you know that you have to convert this to 1 1/6 hours if you're going to do it in hours. If you do it in minutes like I'm doing, then you can just use the 70 here, and then you can convert this over to 240 minutes. So again, you can kind of set it up how you want. You just have to remember what you did in the process and keep it consistent throughout. Okay, so back to the problem. I'm trying to solve K, so I'm going to divide both sides by 1200. I'm going to get a 2. This will always happen when you're dealing with the doubling because you're going to have twice as much on the left as you did on the right. And then I have e to the 30k on top. Now I need to get the k by itself, so I'm going to take natural log of both sides. So natural log of 2 is equal to natural log of e to the 30k. Now I can use my logarithmic rules to bring down 30k to the front, so I get natural log of 2 is equal to 30k natural log of e, and of course natural log of e becomes 1, so I can then divide both sides by 30 and I'll get that k is equal to natural log of 2 divided by 30. And you can either leave this for k in the equation, you can just plug that exactly in here and that'll give you a little more precise answer, or you can just go ahead and get like a pretty nice approximation for it. So let's get an approximation here. Natural log of 2 divided by 30. Maybe we'll go out to 5 decimal places or so. So 0 to 310. So 0231. If you wanted to, you can even go out. We could go out here to 0, 5. We could round it up to 6 decimal places. That'll get us a pretty accurate number here. So now we're going to go put k back into our equation. So we've got 1200 still, and then e, and then now we're going to put in the 0.023105, and then our t. And now we can use this to answer the rest of the question. So after 70 minutes, I just need to put in a 70 here. And put this into my calculator and see what I get. All right, so we'll go over here, 1200 times e to the 0.023105 times 70. And this tells us that we have approximately 6,048 bacteria after 70 minutes. If we want to do it for 4 hours, again, we're just going to do the same thing, but we'll do 240 minutes instead. So actually here on the calculator, I can just pull up the entry and just go back and change this. Instead of 70 minutes, we'll do 240 minutes. And that'll tell us that after 240 minutes, we'll have approximately 307,206, or actually I guess we'll round up to 207 bacteria. So again, just like the other problems, the first thing you always want to figure out is what is that K value going to be, and then from there you can go and answer the questions.